No, of course it can't. It's a notional idea. So it's, again, what a scientist calls a hypothesis, and we test hypotheses against facts. We say, well, what was so special about the pre-industrial level, which happened to be 280 parts per million about, why is that some magic number? And you can only address that question if you look at earlier records of carbon dioxide through Earth history. And we have here a graph which does that. And the left-hand side of this graph now is going back to 500 million years ago. Well, why? That's a long time ago. Why 500 million years? That's a bit longer than the election cycle. Okay, well, why? Because 500 million years ago is when we first find little fossils, which are the ancestors of modern crabs and mollusks and worms and things like that, little marine animals with shells living on the seabed. And from study of those fossils and the sediments they come from, we find that the ocean is chemically very similar to the modern ocean, and the temperature is very similar to the modern ocean. But now look up the graph on the left-hand axis, and you will see that the carbon dioxide level at this time, 500 million years ago, were 15 or 16 times today's level. Not just double, but double and double and double. So the planet at this time wasn't in a runaway warming state, it was in just its normal state. And what this tells you straight away is that enhanced levels of carbon dioxide do not of themselves cause dangerous global warming. Climate's much more complicated than that. There's lots of other factors, and one of the most important is solar effects. But looking at a little detail on this diagram now, we see that those high levels of 15, 16 times today's carbon dioxide only lasted for 100, 200 million years or so on this diagram before they dropped dramatically about 400 million years ago. Now something then is sucking that carbon dioxide out of the atmosphere. And how did it get into the atmosphere in the first place? It came out of volcanoes, of course. So we've had volcanic buildup over time, and now suddenly something starts taking it out of the atmosphere at a much faster rate than volcanoes can replenish it. And that's something, many of your viewers will know, was the evolution of land plants and photosynthesis. And so the plants, of course, take the carbon dioxide out of the atmosphere and they build vegetation, and in some places that vegetation forms a coal swamp and the plants decay and they build up these wonderful coal deposits, great benefits to us on which we've based our whole industrial revolution. So we then dig up the coal and we burn it and we get useful energy from that and cheap energy, and what happens to the carbon dioxide? Well, it goes back into the atmosphere where it came from in the first place, where it belongs. What is the problem?